Okay, this video is about conditional statements. A conditional statement is basically any statement that can be written in the form if P, then Q. P being a hypothesis, and then Q being a conclusion. The P stands for hypothesis, and Q stands for conclusion, kind of has a Q sound to it. We can use symbols to show it when we write P, arrow Q. This reads if P, then Q. And you can see in this Venn diagram that P is totally included in Q, but Q is not included in P. This means that if P is true, then Q must also be true. An example of a conditional statement would be if you eat all your supper, then you may watch America's Got Talent. Okay? So as we look at a couple of conditional statements, we're going to identify the hypothesis and the conclusion. In A, we have if today is Thanksgiving Day, then today is Thursday. The hypothesis in the P is today is Thanksgiving Day. Notice the if is not part of this. And the conclusion would be today is Thursday. Notice again, the then is not part of the conclusion. Okay, if we look at this one, a number is a rational number if it is an integer. Now remember, the hypothesis is the if part of the statement. The if part of this statement is not the first part, it's the second part. So the hypothesis is a number is an integer. Remember, it doesn't say a number right here, but we can't say it without knowing what we're referring to. So we say what it does refer to, and in this case, it refers to a number. So it is an integer, or a number is an integer, is the hypothesis. The conclusion is that the number is a rational number. The number is a rational number. That's the then part of this statement. A number is divisible by 3 if it is divisible by 6. Once again, remember, the hypothesis, the P, is the if part of the statement. In this case, it is divisible by 6. That's the hypothesis. What's it? It's a number. A number is divisible by 6 is the hypothesis. And the conclusion would be it is divisible by 3. A number is divisible by 3. Okay? Now, what you need to understand, though, is that they don't have to be written as if, then. It could be if P, then Q, such as if today is Thanksgiving Day, then today is Thursday. This being the hypothesis, the P, this being the conclusion, the Q. But it could also be if P, Q, such as if today is Thanksgiving Day, today is Thursday. Notice there's no then there. The then is understood. And yet we can still write it as those last two we just looked at, Q if P, such as today is Thursday, that was the conclusion, if today is Thanksgiving Day. Today is Thanksgiving Day is our hypothesis. And yet again, we can write it as P implies Q. Today is Thanksgiving Day implies today is Thursday. That is a conditional statement. And our last one, our last way that we could write it, is P only if Q, such as today is Thanksgiving Day only if today is Thursday. Now, traditionally you will see if P then Q, if P Q, and Q if P. The P implies Q, you will not see very often. The and P only if Q, you will not see that very often either. Okay, so here we are, we have a statement. It's not a conditional statement, it's just a fact. An obtuse triangle has exactly one obtuse angle. And we need to write a conditional statement from this fact. So let's look at what are the two facets of this statement. What is our hypothesis, or our P, going to be? Well, our hypothesis is that an obtuse triangle has exactly one obtuse angle. An obtuse triangle, if an angle is an obtuse triangle, if a triangle is obtuse, then our conclusion is it has exactly one obtuse angle. So then we just write it, if a triangle is obtuse, then it has exactly one obtuse angle. Look at this one. This is a Venn diagram. Well, what does this Venn diagram show us? Well, it shows us that there are blue jays, and they are inside of birds. Well, that must mean that blue jays are birds. So how do we make a conditional statement out of that? Well, what's our condition? If a bird is a blue jay. Well, what is it if it is a blue jay? If an animal is a blue jay, then it must be a bird. So the inner oval is the hypothesis. The outer oval, this one here, that's the conclusion. So in this case, the statement is, if an animal is a blue jay, then it is a bird. Now, it wouldn't make a lot of sense to say, if a bird is a blue jay, then it is a bird. That's a little redundant. We're talking about a specific kind of animal, a blue jay. And if it's a blue jay, it's a bird. Okay, here we have one. Two angles that are complementary are acute. Okay, now complementary means that they add up to 90 degrees. Acute means that they are smaller than 90. So if we have, based on this, if we have two complementary angles, then they are acute. That's a true statement. Because if you had two angles that add up to 90, they must both be acute. So, how would we write this as a conditional statement? Well, first, let's identify the hypothesis and the conclusion. So what's the hypothesis here? Two angles are complementary. And what's the conclusion? Well, they are acute. So how would we write that? As an if-then statement. If two angles are complementary, then they are acute. If two angles are complementary, then they are acute. Okay, so all conditional statements have a specific truth value. Now, that means that the statement can be true or could be false. Oddly enough, there's only one way that a conditional statement could be false. Let's look at a little chart that illustrates this. Now, if you notice, this is the conditional statement. Do you see there's only one that says false? In a minute, we're going to look at why a conditional statement can be false. First, I want to make sure you understand the chart. We have hypothesis, whether the hypothesis is true or false in this, whether the conclusion is true or false in this column, and then this column has whether that makes these two make that conditional statement true or false. You know, it makes total sense that if the hypothesis is true and the conclusion is true, the conditional statement is true. And it makes 100% sense that if the hypothesis is true but the conclusion is false, the conditional statement is false. But these next two are a little harder to think about. If the hypothesis is false, it doesn't matter whether the conclusion is true or false. The conditional statement is true. Think of it this way. If I had a conditional statement such as, if I get paid, I will take you to the movies. Well, if I got paid and I took you to the movies, that's a true conditional statement. But if I got paid and I didn't take you to the movies, that's a false conditional statement. Okay? But if I got paid or didn't get paid, if I didn't get paid, which makes my hypothesis false, it doesn't matter whether I take you to the movies or not. The conditional statement is still true. Okay, I know it's a little confusing. Just remember this rule. The only way you can have a false conditional statement is if the hypothesis is true, but the conclusion is false. The only way you can have a false conditional statement. Okay, let's look at this one. We're going to determine if this conditional statement is true, and if it's not, we're going to give a counterexample. Remember, a counterexample is an example that proves something's false. So this conditional statement is, if this month is August, then next month is September. Okay? Now, let's think about this. If this month is August, then next month is September. Now, this month is not August. Does it matter if next month is September? No. It's still a true conditional statement. If this month was August, next month would be September. That's true. So this is a true conditional statement. Let's look at this one. If two angles are acute, then they are congruent. Now remember, congruent means the same size. Acute means smaller than 90 degrees. Are all acute angles congruent? No, absolutely not. Like a 30-degree angle and a 45-degree angle. Those are both acute angles, but they're not congruent. So that makes this a false conditional statement. Because even if the hypothesis were true, the conclusion would be false, no matter what. Okay, here we have, if an even number greater than 2 is prime, then 5 plus 4 equals 8. Guess what? This is a true conditional statement. Is that crazy or what? Because look at the hypothesis. If an even number greater than 2 is prime, do you know that the only even number that's prime is 2? All the rest of them are divisible by 2, so they can't be prime. That makes this hypothesis false. And remember what we said. If the hypothesis is false, it doesn't matter if the conclusion is true. The conditional statement is true. That's insane, right? This conditional is true because the hypothesis is false. Okay? Determine if the conditional, if a number is odd, then it is divisible by 3, is true. Okay? If it's false, we're going to give it a counterexample. If a number is odd, then it is divisible by 3. Well, let's think about that for just a second. Is 5 divisible by 3? That's an odd number. No, it's not. 5 would be a counterexample for this conditional statement. This is a false conditional statement. They use 7, I use 5, but an example of an odd number is 7, and it's not divisible by 3. So the hypothesis is true, the conclusion is false. The counterexample proves that it's false, the conditional is a false statement. Okay, now it doesn't really matter if the hypothesis is false, the conditional statement is true, no matter what the truth value of the conclusion is. Remember, the only way you can have a false conditional statement is if the hypothesis is true, the P, and the conclusion, or the Q, is false.